80% of the global energy. 95% of the energy required for transportation comes from fossil fuels. For example, anytime we fill up our cars to go for a road trip, or anytime we take a plane to escape from the winter, we are using fossil fuels. Then, it's very important for the oil industry to keep up with the energy demand of the world. For that, they need to keep their operations running safely and efficiently. That means production, pipelines, refineries. However, that's not an easy job. Why? Well, we are dealing with a very complex fluid, crude oil. What is the crude oil? We can define the crude oil as a very complex chemical soup with thousands of different ingredients. There is one group of these ingredients called asphaltenes. They are the heaviest part of the crude oil. Sometimes these ingredients, these asphaltenes, they don't really like to be together with another group of ingredients called paraffins or alkanes. And then they just start flocculating and precipitate out of the crude oil. What happens? We have issues like the one we see on the picture related with asphaltene precipitation. Blocked pipelines, blocked refinery equipment. Then we have to stop operation. That increases the operational cost, decreases production. What I'm doing in my PhD thesis is predicting asphaltene precipitation. How am I doing that? Well, I use models. For example, we know there are complex models to predict things like the weather. So we know the temperature of the next day, and we know if we need to wear one jacket or two. In this case, we have thermodynamic models that allow us to predict when we're going to have asphaltenes in the solid phase. That means phase behavior. But like any other model, we need experimental inputs. So we need to take these crude oils and measure different properties of all these group of ingredients. And do that not for only one crude oil, but for several different crude oils from all over the world. Also including crude oil from Alberta, and including crude oil from, for example, refinery streams. Then, when we have all these properties measured and input into the model, and our model actually predicting asphaltene precipitation, then we can use it in any of the crude oil operations, production, pipelines, refineries, to predict asphaltene precipitation. And then what? The key word, prevention. If we know when we are going to have asphaltene precipitation, we can prevent it. And then, one less thing to worry about to have a more efficient operation to keep delivering the product to our customers. Thank you.